UKG, we provide a solution that unifies HR, workforce management, and pay.
At LiveLink, we provide photo personalization platform to large retailers.
Dun & Bradstreet is a data-driven company.
IDMe is the next generation digital wallet.
Palo Alto Networks is a global cybersecurity leader.
Pager Health is a connected healthcare platform. Our goal is to simplify the healthcare journey.
We came for the ease of entry and we stayed for the performance. As soon as we switched over to Cloud SQL, our response time dropped massively.
The spread of solutions helps us choose the right tool for the right problems. We have Google Kubernetes Engine working in tandem with the Cloud SQL infrastructure.
Google Spanner is at the heart of our ecosystem. Spanner is a highly scalable, fault-tolerant, multimodal, persistent store.
We selected Cloud SQL both in Postgres and SQL Server. We gained automated backups and failover capabilities, reduced operational complexity.
What we love best about Google Cloud is how much AlloyDB AI has allowed us to scale our systems.
The application engineers, they don't have to worry about the performance, they don't have to worry about the latency. Using Alloy with the semantic layer and the API layer has allowed us to drive that efficiency.
Google takes the heavy lifting away from you and allows you to focus on unlocking customer value.
What an amazing video. I always get excited when I see what our customers are doing with our database technologies. Today's session, we're going to cover innovations that we're delivering across Google Cloud databases. My name is Raj, and I lead the product management team for the organization. I'm joined by Sailesh, who leads engineering, and Wenzhe, who's a product manager on our flagship Spanner database. We're also joined by a special guest, Sam Moses from the Home Depot, who's going to share how they're bringing databases to life at their company. So I think most of you are probably at the keynote this morning, and you probably heard Thomas talk about how enterprises are changing how they view data. No longer is it a passive resource or a system of record. Enterprises need data to power systems of action. And that's why we unveiled the industry's first agentic data cloud. We've taken our AI models, our operational databases, and our analytics stack and merged them all into one unified AI native system that lets you unlock the power of all your data, grounded in enterprise truth, and deliver apps and agents at real scale, at agent scale, in real time. Databases are a fundamental building block of the agentic data cloud. We've built in Gen AI into every engine. We've delivered enhanced vector capabilities, and we've integrated with the AI ecosystem, including technologies like MCP, our CLIs, frameworks like LangChain and Llama Index. Today, we're going to cover 3 chapters. We're going to cover how we've built AI into our databases to truly make them AI native, and how we seamlessly interoperate with agents. We're going to talk about how we're breaking down the walls between analytical and operational data to make all of that data accessible in real time to your generative AI applications. And we're going to cover how we optimize our databases for every workload, delivering industry-leading price performance and scale. First, let's talk about how we're building our databases to be truly AI native. So as you all know, our world is comprised of different types of data. We have structured data that typically resides in databases, unstructured data that's often vectorized and embedded in databases or data lakes, and multimodal data that's often stored as objects in object stores. But it's really hard for applications to string these different types of data together. That's why we seek to build database engines that work across all these data types. And we build in, as first-class citizens, AI search with semantic context and adaptive filtering. We deliver the power of generative AI models into your data by allowing you to have AI functions directly in your SQL code. And natural language, as we know, is the language of generative AI. So we support rich natural language support with our data agents platform, including multimodal. Let's talk first about search. As you're probably aware, keyword search may not be enough to meet today's demands. If I go to a typical retail website, I'm not going to find what I'm looking for by knowing the name of a product or the SKU. I need that site to infer what my intent was, and then look at my filter criteria, and then find the right relevant results. That's what we need to vector search for, and that's why we're investing in building industry-leading vector search database engines. And we do this by investing in our own algorithms. Over 14 years, Google has invested in the scan algorithm that's used on our public Google website. We've brought that in to our AlloyDB database engine to deliver 10 times faster performance on filtered vector search queries than you can get with standard Postgres. Up to 16 times faster index creation while using less memory. We know that a lot of our customers have existing data estates that they're bringing to Google Cloud, and they may be using standard PG vector Postgres that leverages HNSW under the covers. Well, we want to meet customers where they are. So leveraging our AlloyDB columnar engine, we actually have accelerated HNSW out of the box to deliver over 4 times faster vector search queries. We haven't stopped there. Just this month, we've delivered support for 10 billion vectors in our scan algorithm. And we've been investing in delivering what we consider the ultimate hybrid search engine. We combine vector search with full text search with user-defined functions, and we rank the results using reciprocal rank fusion to give you the highest relevance. And we're optimizing this even further by bringing native BM25, Best Match 25 support to our search algorithms. So we've talked about search. How do we then bring the generative AI models into your data natively in your SQL? We do this with AI functions. So we've already delivered support over the last year for AI functions like predicates like AI.if, AI.rank, AI.generate, AI.forecast. This week, we're bringing new AI functions, functions that allow you to analyze sentiment and summarize your data, all in line in your SQL as you're operating over your databases. We've taken it one step further, and we know that because we know that cost and price performance is super critical, especially if you're using these AI functions at scale, for example, to predict fraud in your database transactions. We've optimized our functions like AI.if to, instead of just going row by row, calling out to the language model, using intelligent batching to save you costs and to increase your performance. So I mentioned that conversations and natural language is the language of AI. But actually building applications that leverage conversational analytics is extremely hard. It's really hard to get that accuracy when moving from text to SQL. So we've developed an end-to-end data agent developer platform that gives you the building blocks you need to build custom agents that can convert from text to SQL. We provide the tools and the framework and infrastructure underneath to give you the quality, the security, and the governance you expect out of a solution built on the Google platform. A key building block that we're delivering to support natural language is a new tool accessible through MCP called Query Data. With Query Data, you could provide the schema ontologies and query blueprints that really help you refine how that text conversion to SQL is happening. And we provide you the infrastructure to let you hill climb and consistently improve your results, getting to close to 100% accuracy, so you can use this in production applications with your end users for stateless and stateful chat-based applications. We know that security is critical, so we're delivering support for parameterized secure views so the agents only have access to what they're authorized to use. We know that database administrators have a lot of operational challenges, and they consistently have to react when they're managing their fleets, diagnosing performance issues, running manual health checks, and handling repetitive automated tasks. We want to simplify this for our DBAs and help them shift left, get ahead of this action. So we're building a set of database agents, 2 of which that we're announcing this week. We're building an onboarding agent that lets DBAs select just the right database for their workload, You just have to specify your enterprise and performance requirements, and we'll help you with the rest, including helping you provision the databases. We're building an observability agent that's in preview this week that proactively monitors the health of the fleet, including performance and latency, and allows you to provide mitigations on those issues that it finds. We're not stopping there. We're going to be delivering agents that help you code your SQL, help you test production changes before they happen, and help you migrate your databases agentically, autonomously. So not only are you moving the schema and the data, but you're also moving your app logic, your stored procedures, with the help of our agents. So a critical section that we've helped unlock over the last several months is citizen developers who want to leverage our models to vibe code apps. But these apps need databases. So we've done a number of things to enable database support, including integration with common IDEs that help developers vibe code applications, enabling them to access Gemini internally to have an agentic experience while using our tools, and providing data cloud extensions for Visual Studio Code so you can have access to your data from the IDE of your choice. So let's talk about AI Studio integration. Our goal is that with a simple prompt, you can build an application, have it provision a database behind the scenes. We leverage Firestore to give you a generous free tier, but with the ability to scale up if your app goes viral. This is super exciting, so we could bring in a whole new tranche of customers using our databases, building applications, and building new experiences that their end customers love. Here's a great example. See it in action.
You just need to enter a prompt to start vibe coding. Right away, the AI Studio agent gets to work. We instantly get a Cloud SQL database provisioned and ready to go. Preview of the app is loaded on the right side of the screen. Now let us add sample data to this app. Once I enter the prompt, just like that, our database and the app is populated. No need to write any SQL queries. Next, let's make it easy for users to securely manage their own tools by adding a login feature. The agent instantly builds out a login flow and handles all the necessary database filtering to ensure data privacy between users. Now I am logging into the application. Now let's watch how easy it is to iterate. I want to add the actual borrowing mechanism. I am adding the prompt, add a borrow button to each tool card. When clicked, it should link the current user to the tool and update the tool status to borrowed. The agent updates the database schema, updates the app logic, and pushes the UI changes to the app. Now you can see the borrow button in the app preview. Once I click on borrow, the tool gets linked to my profile in the database. Now let us add a smart search feature. To make this work seamlessly, the agent uses database features, including Postgres extensions, to power the semantic search. I am asking, is there a tool to open the can? You can see that a relevant result, a can opener, is shown in the result using semantic search. And we're done. Our app looks amazing. Now with just one click, I can publish this directly to Cloud Run.
Awesome. So I only covered a few of the launches that we're making in the AI space, but we have some more that I've put up on the slide, and also some pointers for breakout sessions if you want to learn more in the next couple of days. With that, I'd like to hand it over to Sailesh, who's going to talk about how we're converging analytical and operational workloads. Thank you.
Thank you so much, Raj. Clearly, you need data to power AI. Now, over the last few decades, the worlds of operational and analytical databases have actually diverged quite a bit. In large part, it's because they have different sets of users, different sets of user journeys. Operational databases are very focused on applications. Analytical databases really focused on business users and data analysts. Typically, there are a modest number of concurrent users, each of them running very complex queries on massive amounts of data. In fact, all of the enterprise data. With applications and operational databases, they may be serving tens, hundreds of thousands, even hundreds of millions of users, many of whom don't even know there's just a database behind the scenes. What they care about is speed. They want interactivity. They want, they want things to operate really fast. And so what becomes important is high concurrency, high QPS, and low latency. Now, it turns out that even for these operational database applications, we've always wanted to analyze them. In fact, a few milliseconds after every operational database application comes online, people start asking questions. If you have a call center application, people want to know how many representatives are idle. Maybe you want to know over the last 5 minutes, what is the wait time for gold customers versus platinum customers? Or perhaps if it's a payment platform, you want to know how much business is being transacted in dollar terms right now. And people want to get this answer right now on the latest data without even having to move it around, right? And so to address these sets of problems, right, they're typically in the admin plane. We announced in Spanner and earlier in AlloyDB the columnar engine. And so this lets you run these queries at blazing speed. But it's not just in the admin plane. This is also useful in the user plane. So for instance, in the context of digital advertising, oftentimes you don't really want to have the same ad presented to the same user more than 5 or 6 times. And so we built in Bigtable counters and continuous materialized views to actually handle these kinds of use cases. Now, it turns out that all the data is not actually in the operational database, of course. One common practice is to tier or offload the data from your operational database to your analytics store. And there's a practice called information lifecycle management. But if you think about the wider space of the lakehouse, with the emergence of open standards like Iceberg, what's really happening is a new architecture where you have all of the data easily accessible by many different processing engines, analytical processing engines and operational processing engines. And that is leading to the new opportunity to really expand how you can converge between these operational and analytical systems. So today, I'm really excited to announce Lakehouse Federation for AlloyDB. So in this architecture, we have BigQuery in the Lakehouse, deeply integrated with AlloyDB, and applications and agents connecting to AlloyDB. There's 2 big things you can do here. One, you can actually query your analytical data, combine it on the fly with your transactional data in AlloyDB, and seamlessly federate queries into your lakehouse. But you can also generate insights by running batch jobs and other kinds of processing on your analytical system and reverse ETL them back to serve these insights with high QPS and low latency in your operational system. Right? Now, if you think about the wider architecture here, as you're converging operational and analytical systems, I covered Lakehouse Federation and accelerated insight serving. A couple of other things. You want to streamline data replication from your operational system, from AlloyDB directly into the Lakehouse. But AI now comes into the picture. We've built the knowledge catalog. We've integrated all our operational databases with the knowledge catalog, which in turn allows you to build high performance, highly functional AI agents. And we've used that functionality in conversational analytics, which we first delivered in BigQuery and Looker. And now conversational analytics can be run on AlloyDB and Spanner in order to have that same admin plane analytical kinds of workloads now be agentic. So it's super exciting time here. Now, we've been on this journey before for our entire portfolio. And in fact, with Spanner, we'd already announced streaming reverse ETL, as well as analytical workloads which can operate on your data without actually impacting your mission-critical transactional workloads using Data Boost. So these were already there in Spanner, and now we're excited to announce that Spanner's columnar engine is generally available. We also have the ability to go and query multimodal data, this, graphs and vectors in Spanner from BigQuery. So these worlds, the worlds of operational and analytic systems, are really coming together. The walls are truly crumbling. Right? And now I'm excited to welcome Wenzhe Kao. She's going to give a demo. Wenzhe is brave. She's going to give a live demo. So let's wish her the best of luck.
Thank you, Sailesh. I'm very excited to be here today to show you the power of Spanner that's built for the agentic AI era. So let's switch to the demo, please. Awesome. So imagine a global retailer, SimpleMart, wanting to build an intelligent, personalized shopping assistant. This assistant doesn't just look up for items. They understand customer preference, product relationships, as well as market perceptions over millions of SKUs worldwide to make instant, context-aware decisions. So let's just start here at the SimpleMart's digital storefront. Suppose I'm setting up a home office and I need a chair. So let's just type in chair for a basic search. Spanner's full text search integrates the same query understanding that powers Google search. So here we immediately see 7 results. You see some office chairs there, massage chair, as well as recliner because it understands synonym. But we can do better by using hybrid search. So combining the traditional token-based search with a semantic prompt like comfortable chair for back pain. Now you see Spanner can generate a unified search result. We see some ergonomic options that probably will be simply missed by using a keyword search. I want to take you behind the scene. In Spanner, you actually can write this unified query. Spanner is fully integrated with the Gemini Enterprise Agent Platform Model Garden. You can use a simple ML predict codes to generate the embedding of your input text at the execution time of your query. Additionally, I think we talk about hybrid search. So Spanner also uses Google proprietary scan index for ANN search that cross text as well as image. And we union together with token-based search. And we also use some customer ranking to give you a final result. What is more, we actually are not pulling data from a search engine and a vector database. Everything here you see, the full text search and the vector embeddings, as well as the relational data, they're actually all coming from the same table defined in single DDL. So this really significantly reduced architectural complexity, ensure data consistency, and making sure that your AI is grounded in your fresh data. Okay, so search is only half the story. So let's say we want to drive conversion and we want a personalization. You can also using Spanner Graph Rag via LangChain to build email marketing campaign that tailor to each individual customer. I want to give you a sneak peek of the workflow behind the scene. So by Spanner, we can intercept this query. As you can see, Spanner basically can use semantic vector search to find products semantically similar to the customer's last purchases. At the same time, they can also pull the relationship from your graph-based data to understand, like, for example, product often bought together in one go. So we did a lot of we show you a lot of capability of the operational databases of Spanner. What about those market insights that your data science team is processing in BigQuery? Traditionally, if you want to take those insights back into your operational database, then you need to build ETL pipeline. Well, not anymore. So with Spanner's streaming reverse ETL, we actually can use BigQuery's export data function to continuously writing the data back into Spanner. So that way, whether that's like your performance metric aggregation or sentiment analysis, you can directly serve back to your operational application with high concurrency and low latency. Finally, I want to take you to the agentic era. Instead of a standard search box, now we can actually directly talk to your databases using conversational analytics via a data agent. So let's say we're asking the question, show the top-rated chair for a home office with description and price. So this agent doesn't just guess. You actually have grounded access to your operational data. So you will query the database, reason through your results, and generate a natural response answer. As you can see, there's a very neat table that's out there. It gave me 3 products. They're also kind of summary for me. Look, this like office chair with lumbar support sounds like a great bargain because it has the best review and also the best price. In just 5 minutes, I show you all the building blocks of your agentic AI application. It includes interoperable multimodal capabilities that can provide your agent with real-time, consistent data, whether that's for hybrid search or graph rag. It also can provide you this unified data intelligence by bridging analytic insight with your operational data. Last but not least, it also gives you a natural interface so you can engage with your customer in natural language. All this capability is building on Spanner, the highly scalable, available, consistent multi-cloud databases that's ready for your next AI application. With that, let's switch back to the presentation, and back to you, Sailesh.
Thank you so much, Wenzhe. Well, it's no wonder that customers love Spanner. Spanner's growth has truly exploded over the last few years. And as much as people love Spanner, there's a few things they've been asking us for. The first is business continuity. People want to go beyond the boundaries of their cloud. Sometimes that's for availability and resilience reasons, and sometimes it's optionality for stressed exit scenarios. Data residency is a second case for perhaps regulatory restrictions, perhaps it's economic imperatives. People want to run on their own data centers. Multi and hybrid cloud strategies, it's a reality in today's world. Many of our customers, many of you all are juggling investments in multiple clouds. And there is, unfortunately, that small set of customers who are not on Google Cloud, but would love to use some of the most compelling features of Spanner, like Graph. And so today, I'm super excited to announce Spanner Omni. With Spanner Omni, we are going to have Google scale in your own infrastructure. It's a downloadable version of Spanner, and Spanner Omni can process millions of queries per second across petabytes of data in a single deployment. And so you have the big capabilities of Spanner today, right? Infinite scale, availability, consistency, and all of these amazing multi-modal capabilities. And now you can run them in a few different deployment options. One, in Google Cloud, on Compute Engine and Kubernetes. In other clouds, starting with AWS and other clouds coming soon, and on premises in your own infrastructure. And you can mix and match these. You can have deployments across all of these configurations. So we're really excited about Spanner Omni. And as Wenzhe just said, it's the multi-cloud database now, right? And so customers are already using it. Early customers, they're excited. They're raving about it. For instance, Mercado Libre talks about how Spanner Omni is enabling true cross-cloud resilience, really letting them have a very differentiated strategy, especially for a highly regulated customer like Melly, and really giving them the ability to execute an ambitious strategy that they just could not possibly accomplish with any other cloud provider. Now, I talked about a bunch of different launches today. Some of them will be covered in a lot more detail in upcoming sessions, so certainly encourage you to come on and go to these sessions. One of the things that reasons we went down this journey of convergence of analytics and operational databases was because of what we heard from our customers. In fact, a few years back, some folks in Home Depot sat us down and said, come on, guys, you've got to make it easier to connect your analytics and operational databases. So it's particularly exciting to have Sam Moses here, who's the VP of Data at Home Depot, and he's going to talk about their vision for how they use Google's Data Cloud. Thank you, Sam.
Thank you, and thank you for having us. As the world's largest home improvement retailer, I'm certain that many of you all have heard about Home Depot before. We're proud of the role that we play in helping our customers solve problems and build dreams every day. Operating more than 2,300 stores across North America, we aspire to excel in customer service. We aspire to excel in our service to our associates, to our communities, as well as to our shareholders. Our incredible team of over 465,000 associates are the heart of the Home Depot. Their knowledge and passion make the difference for our customers every day. In 2025, our sales surpassed $160 billion, a testament to the trust that our homeowners as well as our professional partners place in us on a day-to-day basis. We're constantly innovating to make their experiences with shopping with us much better and to make their experiences more frictionless. And our focus on technology helps us to create this seamless, interconnected retail experience for our customers, whether they're shopping with us online or they're shopping with us in our stores. At the Home Depot, we are a data-driven company. We use a significant portion of the Google Cloud product stack to power our operations and to deliver the best-in-class experience for our customers. Operational databases like Bigtable, Spanner, Cloud SQL, AlloyDB are all critical and they solve for different use cases that help us to deliver responsive, personalized, and secure solutions at scale. Our massive, over 15 petabyte data warehouse runs BigQuery. Coupled with data flow to manage our data pipelines, we are able to gain real-time insights along with historical data we need to make smarter decisions. The entire data cloud ecosystem is how we stay ahead, constantly evolving and finding more ways to make home improvement experience better for everyone. I'm sure many of you in the audience have used HomeDepot.com. If you haven't, I would encourage you to go out and take a look at our site and give us a chance. Our commitment to customer experience goes beyond just providing a great selection. We strive to personalize every interaction. This means suggesting products that truly match your needs, thus making your shopping experience smoother and more efficient. It all starts with the browsing activity, what you click on and what you purchase. The session activity is captured and processed in real time using Bigtable. Simultaneously, we're uploading your purchase history and analyzing that through our powerful data warehouse in BigQuery. By combining these two sources, Bigtable and BigQuery, we're able to analyze extensive customer data and to create a variety of machine learning models that then help us to generate these personalized recommendations. These models are deployed using Vertex AI, and they power some of the useful content that you see on the site. Some of the examples would be where we make the recommendation for frequently bought together items, or where we may say customers ultimately purchase a specific product solution. Just in time for spring, as many of you heard this morning in the opening session, we are expanding Magic Apron. Magic Apron offers a suite of generative AI tools that help our customers find the answers to what they need relative to their home improvement projects. Magic Apron is available today through the Home Depot app. It's also available on millions of products online on HomeDepot.com. This first-of-a-kind technology, Magic Apron, is powered using a proprietary home improvement knowledge base. This knowledge base combines large-scale knowledge of our internal knowledge and internal associates, coupled with detailed product knowledge and product information. It's like having a trusted associate right in the palm of your hand or right there on the screen to help you to guide the decisions that you make. Again, I would encourage you to go out and take a look at Magic Apron if you haven't had a chance to use it. In order to power Magic Apron, we use multiple tools, spanning transactional systems, proprietary ML models, GNBI, as well as information from our unstructured data sources and data assets. I'd like to take this time just once again to thank the Google team, thank the Google Cloud team for having us today, and I'll turn it back over to Raj.
Thank you, Sam. Thanks for the great presentation, and thanks for being such a great design partner and keeping us on our toes. We do focus on our customers, and the way we do that is we want to be optimized for every one of their workloads. That's why we invest in a full slate of database offerings, from in-memory to relational to key value to document databases. And we meet our customers where they are by embracing open standards, whether that's Postgres or MongoDB or HBase or Cassandra, Valkey or Redis. We are investing in all of our databases to make sure that we meet the needs of customers like Sam, like the Home Depot. But it's not enough just to meet open standards. We also need to provide differentiated openness. How do we give our customers the best price performance? How do we give them the best scalability? Well, a great example of that is work that we recently did with Bigtable. As many of you who may have used Bigtable know, it is an extremely fast database. It can support reads and writes of less than 10 milliseconds. But sometimes there's applications that come along that need even better latency characteristics. Applications like ad tech, MarTech, applications like gaming, some financial applications often need sub 1 millisecond latency. So typically the way our customers achieve this is by putting caching layers in front of their databases. And we have many examples of customers who traditionally have taken Bigtable and put memory store, for example, in front of it. But this does add additional layers of complexity and additional management burden. So to solve this problem, I'm excited to announce that we now have Bigtable in-memory tiers. We deliver sub-millisecond read latency as part of a new Bigtable Enterprise Plus edition. And so these new nodes employ hybrid storage. They're able to span across the in-memory cache, the SSD, the HDD, and automatically do the lifecycle management of data to make sure you have it exactly when you need it. It eliminates hotspots by automatically supporting sharding. We provide ease of management because you're using the same database. You don't have to manage your own separate caching infrastructure, which gives you a simple and consistent experience working with your data. Talking about low latency, high throughput applications, our leading in-memory database is Memory Store. And we continue to innovate on behalf of our users on Memory Store, starting with the launch this month of Valkey 9.0 GA. With Valkey 9.0, we provide the enhanced reliability, performance, and memory optimizations that our customers have asked for. But more so, we make it super easy to migrate to Valkey. Now we support one-click migrations from self-managed Redis and Valkey to Memory Store for Valkey. We know price performance continues to be a critical aspect of how our customers evaluate our offerings. So we've expanded our node sizes by both on the small end and the larger end, providing 5 additional node sizes that map to common patterns that we see with what our customers need in terms of memory and CPU to power their database applications. We've also invested heavily in enterprise security enhancements, including Valkey password-based auth, ACLs, and flexible certificate authorities to further expand our security posture. Many of our customers rely on Oracle to support their mission-critical database applications. But they would also like to activate their Oracle estates with the analytics, with the AI that we bring to Google Cloud. So we've partnered with Oracle to take really the best of both offerings. Oracle for its mission-critical database infrastructure, we brought that across our global footprint. Just a year ago, we were only in 4 regions. Now we're up to 15 and growing fast. We've now integrated Golden Gate 26 AI as a managed offering on top of Google Cloud. So now you can move data to BigQuery to support near real-time analytics on your operational data and have low-impact data movement from on-premises to your Oracle estate. Our Oracle customers love the idea of leveraging AI against their databases. So we now have rich support of AI integration, including supporting Oracle through MCP. So your data agents and generative applications can leverage your Oracle data seamlessly. We support knowledge catalog integration to support unified governance across your whole data portfolio, including our first-party databases and your Oracle estate. And finally, Database Center now supports Oracle as a place where it could provide AI-powered recommendations along with our other first-party databases. So we have several more launches that we've made across our database portfolio to meet their users where they are. I've listed a few above. And that really brings us to the end of our presentation. But I wanted to leave you with a note. We talked a lot about the innovation we're driving in AI. We've talked a lot about how we're breaking down the barriers between operational and analytical data. But one thing remains constant. As we're innovating on your behalf, we're ensuring that we stay true to our mission to support planet-scale workloads. Google's planet-scale workloads are built on our database offerings, so we hope to serve you just as well with your own workloads. Thank you so much for coming to this session. Hope you enjoyed some of our other sessions, and hope you enjoy the rest of the week. Thank you so much.